Okay, so welcome to today's class again. So in today's lesson, we are going to give you a trick that you can live by when it comes to electron configuration. So this trick I am about to show you, you won't see it in a book. Okay, so let's get it moving. So we know fully well that the periodic table contains 4 blocks. They are the S block, the P block, the D block, and that of the F block. So this is a periodic table. If you look right here, they are the S block. It contains 2 groups, group 1 and group 2. So right here is the P block. It contains 6 groups, 1, 2, 3, 4, 5, 6. And in between here is the D block. It contains 10 groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here is the F block. It contains 14 groups. When you check them, they are all 14. Okay, so I'm going to show you a pattern that you can use to configure any element on the periodic table. So we will use this simple step. How many letters are here? There are 4, right? 1, 2, 3, 4. So we can name them or label them as 1, 2, 3, 4. So the next thing is we can draw an arrow above that. We can draw an arrow right here. What does the arrow indicate? It shows that you are leaving from this position towards this position because it's going this way, right? Okay. So it means that we'll leave from back to come this way. Okay. If we're trying to configure any element, like maybe we say carbon, we have called carbon is element 6, and it can be found in group 4 or say group 14 of the periodic table, and carbon forms 4 bonds, right? Carbon forms 4 bonds. Okay, so to do this, we are going to write down the diagonal theory that looks like a snake pattern. That is a diagonal theory, but mostly teachers just draw that on the board and give it to student without telling them the origin of that. So it actually came from this aspect. Tell a trick that I capture. So to do this, we will use this pattern. This arrow go this way from back to this front, and we will double them. We'll make them 2. Example, we say SS. Arrow means from this side to this side. We'll say PS, PS. We'll go DPS, DPS. It should be double. FDPS, FDPS. Right? Okay, let's move. So here now we say SS. So each letter should be on each letter. Like we say SS, S on S, P on P, D on D, likewise F on F. So we can say S, S. Or the next thing is PS. We write P right here. We should not write P here because P was in front of the S here. It was just SS. So now we say PS. We write S here. We double. We say PS. So P on P, S on S. The next thing is we say DPS. We can write DPS. We double TPS. We write TPS. The next is FDPS. We write FDPS. FDPS, we double FDPS, where FDPS. Okay, so when you look here, S is the first one right here. S begin with 1. So S will start with 1. We will start S with 1, 2, 3, 4, 5, 6, 7, and 8. P start with what? It start with 2. So we put 2, 3, 4, 5, 6, 7. T start with 3. 3, 4, 5, 6. And S start with 4. So we say 4, 5. So this clearly shows that there is no one P in configuration. No. Because P is at its second position. So there's no one P. So P start with 2. So you can say one P is there, one P that. No. Likewise, T start with 3. There's no 2D. T starts with 3. Likewise, 4 start with, likewise, rather, F starts with 4. So there's no TDF. Hope you understand that based on this concept right here. So here now we'll put 2 above all the S. Why? Because the S block contains 2 groups. Here's the S block. It contains 2 groups. Group 1 here and group 2 right here. So all the S has 2. Those 2 you see up here, they are all electrons. They are all electrons. And the P block has 6 groups. When you look here, 1, 2, 3, 4, 5, 6. So all of the P you see here will contain 6, 6, 6, 6, 6, 6. What about D? D has 10 groups. Here's the D block. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the D carry 10. So they have 10 electrons maximum. They have 10 electrons maximum in their shell. So what about F? Is 14 groups. If you check this, there will be 14. So all the F carries 14. So the next thing is to draw an arrow in them so we can get confused. So to do that, first we say S. S, S. So the first one was the first S, we draw the arrow like this. Then we say S again. The next thing we do was we say PS. So we draw it based on how we wrote them. Then we say PS again. So we do it like this. The next was DPS. And we say DPS. The next was FDPS. 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 So this is the diagonal theory. It was how it came about or formulated. You can try to write it properly, like making the arrow this way, but this is the actual concept. You should make sure that the arrow is being passed through how it was written, not to get confused. So you can also read this and we can configure carbon. So in so doing, we can say 1s, we can write 1s2, we can write, but from this going to this, we can write 2s2. The next is here, we leave from the back to come to the front. So we say 2p comes before what? 3s, not 3s before 2p. Okay, that clearly. That's why the arrow is being drawn to give you indication. So that's how the arrow has been drawn to give indication. So this means that you leave it from the back to come to the front. The same thing that we did here. So don't say 1s2, 2s2, 3s2, then go to 2p. It will be wrong. Instead, you should leave from here and come here. From here, you come here, here, till it continues. Just look at the arrow. So the next thing is we can say 2p6. So we can write two pieces, and there is 3s2, and there is 3 pieces, 4s2, 3d10, 3d10, 4 pieces, 5s2. The next is 4d10, 5 pieces, 6s2. Then the next is, we can say 4f14. It can fit, so we bring it down. And the same thing, you can make it long if you have chains or there's a space there. So you say 4f14, 5d10, 6 pieces, 7s2, 5f14, 6d10, 7 pieces, 8s2. So if this is giving hard to write, you can do it like writing this. If you have this, it becomes more simple as a whole again to configure any element. Either use this or you use this. Remember, this came from this and this came from this, but they are all the same if you want to configure it using either this or this. Okay, let's take an example. They say configure carbon. Carbon is element 6. So let's use this first, and we use this to configure carbon. So we can say like metal 1. Here we say metal 2. Remember, it's the same thing. So carbon is element 6. Remember, we are checking those electrons that you see up here. And what we're checking, not the one at the if one here to reach to 6. No, it's the one that is up. It's electron. So here now, carbon is element 6. To configure that, using this, we can say 1s2. So I will say carbon. We can say 1s2. So it becomes 1s2. Carbon is element 6. We have consumed 2 electrons. How much left to negate 6? But now 4 more. So the next thing is 2s. We have 2s. How much is here? Is 2. It's 2 right here. How much more to negate 6? But now 2 more. What go here next? Go to the next area. We say 2p. We have 2p. Here now, when you write the entire 6 down, or when you subtract, don't write the entire 6 down. If you put 6 here, it means that we have total to be 10. So it will be, you are saying 6 plus 2 plus 4 give us 10. And that won't be carbon, it will be neon element 10. So in configuration, the maximum number, you cannot cross that, but you can minimize it based on which element you are configuring. Like we say carbon is element 6. We have consumed 2 level, right? So we can say 2p 2. 2, it gives us 6. So this tells that the element carbon can be formed in the P block. It can be formed in the P block, the second row of the P block. So we look right here. Here is carbon. Here is carbon right here. We say it's in the P block, and we say this area here is the P block. So carbon is in group 2. So this tells us carbon is in group 2, the second row. So here is group 1 of the P block. Here is group 2. Right? So carbon is in group 2 right here. They said the second row 1, 2. So you find carbon right here. So it is how elements are being positioned on the periodic table. Okay. So what if we want to use this to configure it as a whole for carbon? We can just say 1s, 1s2, 2s2, and 2p. We drop the 6 to make it what? To make it 2. It becomes the same thing right there. So it's very, very easy. I hope you learned something new and you can give this a try. So try this or try this. Also, oxygen, neon, and calcium. So please try to configure those elements and give your answer in the comment section. Thank you, and love chemistry today, do chemistry tomorrow, and live with chemistry, because no one does it better than chemistry. Remember, chemistry is essential science. Yup, love it, live by it. See you in our next video.